Hello everyone, welcome back to another Math Your Day channel. Right, so in today's video we'll be of course doing the exponents. Right, we finishing off from yesterday's work. Right, so we did the basics of the exponents. Let me just put these. We did the basics of exponents, right? So, and we did some examples, right, on how to simplify. So now in this case, we will look at how to solve for x, right, when dealing with exponents. So let's look at number one, right, question one. So you can see here you have 3 2x minus 12 is equal to 1, right? So in order for us to solve these, remember that we said, or rather we didn't say, but take note of if a is equal to n, I mean if a to the power n is equal to a to the power m, automatically n will be equal to, in that case, m, right? Because we want these two things to be equal. Now if these are equal, therefore these has to be equal too, right? So that's what we are trying to do when dealing with exponents, right? We want to find the same basis, and then it just equates we equate the exponents. So you will get some like quadratic equations, but yeah, we will solve that later on, right? So now let's look at the easy ones first, right? So you can see here 3 2x, I mean 3 to the power 2x minus 12 is equal to 1. So we did say yesterday that on our prior lesson we said that a to the power 0 will give us 1. So meaning where a is an element of real numbers, so meaning a can be any number in that case. So if you want the basis to be the same in this case, we have to change that 1 minus 12 to be same base, right? 3 and 3, and then put the 0 there, right? So you can see that this expression is the same as that one there on top. So meaning we can just equate the exponents. So meaning 2x minus 12 will be equal to 0, and therefore 2x is equal to 12. Divide both sides by 2, right? And then of course the v2 will move, right? Therefore you got x is equal to a 6, right? To prove that, right, if you take this value here and plug it in here, in place of x, you should get a 1, right? So meaning 3 2 times a 6 minus a 12, right? So 2 times 6 is 12. 12 minus 12 is 0. So meaning we get 3 to the power 0, which is basically 1, right? So meaning this value here is correct, right? Then if you look at number 2, right, remember that we want the bases to be the same, right? So you can change this on your calculator. Of course, this will be 5 is the same as 5 times 2. 5 times 2 is 10, so therefore x there, x plus 1. Then if you change this one here, yeah, you notice 4 times 5 is 100. So 4 is 2 squared, and then 5 is 5 squared, right? Then we can simply take put these two in one bracket, then square. So why are we doing this? Remember we said the last time when we have a times b to the power n, what will happen is the a and the b will both receive the n. So in this case you can see that here they are both common with the 2, so meaning you can take the 2 outside, right? Can take the 2 outside. So in this case we can see that this base here is basically the same as this base here, right? or you can just do like 5 times 2 here, right? So these bases are basically the same. So what we do, we equate the exponents. Therefore x plus 1 is 2. So in that case, you got x squared. You solve this as normal equation. Plus x minus 2 is equal to 0. And then in that case, we have x here, x, 2 and 1, right? Therefore, this should be a positive and negative. Therefore, x should be a negative 2 or x should be a 1. So to prove this again, we're going to take the negative 2, plug it in there, and let's see. It should give us 100. So 2, negative 2, negative 2 plus a 1, right? So you got 10, negative 2. Negative 2 plus a 1 is a negative 1. Negative 1 times negative 2, that's 2. So 2 squared is 100, which is correct. And then you check the 1 also, it should give you 100. And then if we go to number 3, so here is basically the quadratic equation, that I was talking about. Or you can do this in 2 ways, right? You can do this in 2 ways. So the first way, the easiest way, is to say, well, 5, if in that case I take 5 over 1, then I say x, right? No, that won't work, that will not work, right? Okay, let's just stick to the quadratic one, which is long. So what we're gonna do is let's first change this negative here. Remember how to change a negative. Remember when we said a negative x is the same as 1 over x. So in this case, again, you can say this is 1 over 5x, which is equal to 2. So how do we get rid of this 5x here? So we have to times both sides by what? By 5x. So meaning can have 5x here times 5x plus 15 times 1 over 5x is basically whatever you do on the right hand side, you do on the left hand side, right? So if you take this one, the bases are the same. You add the exponents, therefore 5x plus x, this is 1, 1 plus 1 is 2. Put the x there, then that times that, you can see that these two will cross cancel. Therefore we have plus 15 here, which is basically 8 times 5x. Then you take the 8 times 5x to the left, right? So you have 5x minus 8, 5x plus 15, which is equal to 0. And therefore this is a quadratic equation. So most of you all will use let 5x equal to k. That's fine too, but to not waste your time, you can just say 5x here, 5x here, and then this will be 5 and 3. This will be negative and negative. This is 5x equal to 5, or 5x is equal to negative positive 3, man. Sorry about that. So it should be positive 3. So what we do here, we notice bases are the same. Equate the exponents, therefore x should be 1. And here there's nothing we can do about this one. We can just introduce the logs, right? Logarithmic equation, properties, right? So here we have 1, because there's a 1 there, so log 3. So you can divide everything by log 5. Here again by log 5. Therefore these two will move, and hence x will be, if you plug this in a calculator, log 3 divided by log 5. So it's log 3 of log 5, which is 0. Where's the 0.6826, right? 0. Yeah, you round it off to the nearest 2 decimals, right? 0.68 in that case. Okay, so now looking at this one here, the final one here, this one again kind of look complicated, but it is not complicated, not that complicated. Remember that last time we said whenever you have these, you can see here you have 5x, here you also got 5x, here you also got 5x. So what we can do is we can isolate these terms on one side, right? So what I mean, we can have 5 plus x minus 5x. Take this on this side, 5x times 23, which is equal to 1. Now that we have isolated that, so you can see that 5x is common in all these 3 terms here. So you can take out 5x, right? You can take out 5x, and then what you have is we have 5 squared. Why? Because this here, if we say 5x, 5 to the power x times 5 to the power 2, if you times these, the bases are the same, you add the exponents. Therefore x plus 2 or 2 plus x will give us that. So here you basically have -1, then here you got 23, and you just plug this on your calculator here. So this is 25 minus 3 is 2, minus 1 is 1, therefore you got 5x, which again here we change this to a 5 to the power 0, so you got 5 power 0, therefore x should be equal to 0. Therefore if you take the 0 there and you plug it in the original function, we will have 5 2 plus 0 minus 5, 0 there, and then is equal to 5, that's 0, times 23 plus a 1. So this here is 25 minus 1, so this is 1. 1 times 23 is 23 plus a 1. So 25 minus a 1 is 24, and then 23 plus a 1 is 24. So meaning the left hand side is equal to the right hand side. Therefore it is correct. So simple as that, guys. Not that difficult. Yeah, but we'll look at more questions related to exponents, right? Yeah, with exponents. And then yeah, that's it for this video. Hope you enjoy. If of course again you didn't hear clearly, or there's something you don't understand, comment down below, right? And just say whether rather where you struggle, or where you didn't hear, or maybe I made a mistake somewhere. Just comment down below and I will definitely do another video explaining these exponents, right? So thank you for watching, and I'll catch you later. Cheers.